today we're going to do some infinite series using limited of n approaching infinity. So the first problem is limited of n approaching infinity is 2 minus 2n over 6n. So your first step is you're going to take the limit of n approaching infinity. So you're going to take your highest n, which is the first one, and you're going to divide all that from the top. So it'll be 2 over n minus 2n over n over 6n over n. Okay, so what you do next is you're gonna cancel all the n's. So this will be equal to limited of n approaching the infinity of 2 over n minus 2 over 6. Okay, and now what we're gonna do is you're gonna break these up. You're gonna syncopate it. So you're gonna take the limit of n approaching infinity of 2 times the limit of n approaching infinity over 1n minus the limit of n approaching infinity of 2 over the limit of n approaching infinity of 6. Now with this is going to equal to 2 times 0 minus 2 over 6. Now the 2 times 0 was really equal 0, so they cancel out. So this will be equal to negative 2 over 6, and that will equal to negative 1 over 3. And that is your answer. Alright, for the next example, you're going to have 2. This is number 2. So you have limit of n approaching infinity over 6n squared plus 2n plus 8 over n squared. Now since n squared is our highest, we're going to divide all this by n squared. So you can take the limit of n approaching infinity over 6n squared over n squared plus 2n over n squared plus 8 over n squared divided by n squared over n squared. Now this will be, this is going to equal to the limit n approaching infinity. This will be 6 plus 2n plus 8 over n squared over 1. Now you're going to take the limit of n approaching infinity, 6 plus the limit n approaching infinity of 2 times the limit of n approaching infinity of 1n squared plus the limit of n approaching infinity of 8, I'll bring it down here, times the limit of n approaching infinity of 1n squared over the limit of n approaching infinity over 1. So this will equal to 6 plus 2 times 0 plus 8 times 0 over 1. Now since 2 times 0, they're all going to cancel. So all you're left with equals is 6 over 1, which will equal 6. And that's how you do infinite series and limited limit over n approaching infinity. Hi guys, well, I'm here to explain arithmetic sequence and series.
So first, I'm going to start by giving you some formulas that we can use. The first formula is going to be A2 minus A1 with A3 minus A2. That's one way to find the arithmetic sequence and series. Another formula that we're going to use today is Sn equals n over 2 parentheses a plus an. So these are the two formulas we're going to be using today. First example is find the sum of the first 32 terms of the arithmetic series -12, -6, -0, plus all the way to 174. I'm sorry, not -0, just 0. So to find this, we're going to be using the second formula. Why? Because since it's a bigger number, like 32 terms, this formula is going to take us 32 times to find the answer. So it'll be easier to use this one. So n would be the terms. So we would go S32 equals n, which is 32, over 2, parentheses a, which is A1, A2, A3, etc. So it's asking for A1. So it will be -12. Plus AN. AN is pretty much the last number they're giving us, which will be 174. After that, we'll just pretty much simplify. 32 over 2 would be 16. And bring the rest down. Then simplify these, which would be S32 equals 16, 162. A lot of people make mistakes. Make sure to put the parentheses there because you're not adding, we're multiplying it. After you do that, you multiply 16 times 162 and the answer would be 2,597, as I was, 92. And that's how you get your first answer. Now, second example. Find the sum of the first 50 terms of the arithmetic series -6, 1, 8, and the last number, an, will be 337. Now I'm not going to write all this again, so I'm just going to put the terms, which is 50, and the three numbers, which is -6, 1, 8, and the last number will be 337. Now, to solve this, we will be using the same formula. Now, like I said, we could use this one, but I'll explain shortly after we finish this why we're not using this formula. So to start off will be Sn. S will be 50, so it will be S50 equals n over 2, which will be 50 over 2, parentheses, A1, which will be -6, plus an, which would be the last number, which would be 337. Parentheses. That was right here. 2. My mistake. 50 over 2 would be 25, obviously. Then bring the rest down. Simplify these. Make sure you still keep them with the parentheses. This would be 331. And then multiply them, which will be 8,275, which will be your answer. Now, lastly, to use this formula for the arithmetic sequence and series, I'm going to do it right here because it's really simple and short and quick. The question will be, find the next 4 terms in the arithmetic sequence, -10, -6, and -2. Trying to make us find the next number, the 4th. It could be asking the 5th, the 6th, doesn't matter. It's asking for the 4th. So it's giving us 3 numbers. It's giving us -10, -6, -2. And the 4th number we want, right? So, how do we find that? Okay, that's where this comes out. This is A1, A2, A3. So, the formula will be A2 minus A1. So, A2, which is -6, minus A1, which is -10. Me, I put the parentheses, -10. Doesn't matter how you guys do it, just make sure it's a negative. Then, A3, which is -2, minus A2 again, which is -10. Hold on. A2. Gotta check my work, guys. A3, -2, A2. Okay. So, to solve these, I would get 4 and 4. Right? So that means if we get these the same number, we're obviously going to be adding by 4. So -10 plus 4 equals -6. -6 plus 4 equals -2. -2 plus 4 equals 2. So the answer would be 2. So pretty much you're just adding 4, adding 4, adding 4, and that's how you get this answer. But if it was going to ask for the 5th, let's say it wants a 5th, then you just add another one. So 2 plus 4 equals 6. So that'll be your answer for if they were asking for the 5th number. And that, guys, conclude this presentation for school. Yeah, arithmetic sequence and series.
First, let me hop out the motherfucking Porsche. I don't want it if that ass don't sit like a horse. I be ballin' on these niggas, got me feeling.